Hi everyone, welcome to this webinar from Varnish Software on delivering powerful web functionality at the edge. It's great to have you with us. I'm Ian Vaughan and I'll be hosting today's session. And I'm delighted to introduce our special guest, Guillaume Cantar, who is Technical Director here at Varnish. Hey Guillaume.
Hi everyone. Hi.
So let's see what we're going to be talking about today. So on the agenda, we're going to look at the shift to edge computing, and we'll start by sort of talking about what the edge computing actually is, telling a story of how we got to now and this movement of sort of workloads towards the edge. And we'll talk through the history of sort of the network and the infrastructure and how we got to where we are today and why we're seeing that shift as well. And then we'll talk about what you're actually able to do at the edge today in terms of use cases and workloads that you can offer or take advantage of, the benefits of doing so. And then we'll look at topics around what you need to succeed if you have an edge strategy in place, if you're rolling out edge services, what kind of software and hardware do you need to look for? What kinds of optimizations do you need to make to successfully handle sort of the demand, the latency, capacity, throughput demands of different edge use cases? And then we'll touch on sort of what comes next, just to look into the near future of this topic. But I wanted to start today just with two numbers, just to put things in context, I suppose, about where we are and why we're talking about this today. So 50% of enterprise managed data will be created and processed outside the data center or cloud by 2025. 13.9% is the growth rate of the enterprise market for edge content distribution, security, and compute services. Both those figures are from Gartner. So we're seeing a real movement toward the edge for all kinds of workloads, use cases. So it's just interesting to see that something's happening in the industry and in the market that is sort of causing this. So that's what we're here to do today, is explain and examine what's going on. The reason Guillaume and I are here is we work at Varnish Software, who are a provider of software solution called Varnish Enterprise. So you may have heard of the popular open source reverse proxy called Varnish Cache. So we're also the main stewards of that project. And it's really the Varnish software suite, if you will, is a solution for sort of enhancing and accelerating delivery of all kinds of web applications, video streams, objects, APIs, artifacts, sort of anything that uses the HTTP protocol, you name it. It will be sort of, you'll be able to accelerate its delivery with Varnish. Guillaume might correct me there, but I think that's the general outline of Varnish.
Yeah.
So
No,
I mean,
you're
yeah.
doing a great job.
Thank you. That does actually mean a lot. So with obviously Varnish, every day we're working with businesses, enterprises who are looking to move sort of content distribution, delivery processes closer to end users, right? We can see from this simplified diagram that when you're looking at a round trip time that's in the hundreds of milliseconds and the time it takes for the sort of back end server to process, when you need to sort of deliver that quality of experience, that resilient service, adding something like Varnish into the mix and moving sort of caching of the content or the objects or the APIs closer to a user can result in a much better experience while offloading that traffic. So we're in the edge world. We're all about moving things closer to end users. So that's why we are here. And that's why we're interested in this topic and having this conversation today. But now I think this is where we can sort of take it back, tell the story of how we got to this point, where we're seeing that growth of the edge market, of edge services, and how we got to this point. So shall we give a quick history of the network?
Yeah, very, very abridged, but very relevant history of the internet. I won't bore you too long. But back in the old days, we usually only had one POP, one point of presence, usually located where the people maintaining it were. There was no cloud. And that monolith and single point of presence would cater to everybody on the planet, which, as the World Wide Web grew global, that's starting to be kind of an issue because, as we've seen in the previous slide, well, speed of light is finite, and so every user needs to do a round trip for every single resource. And that takes a lot of time cumulatively. So some people thought, you know what, maybe we don't need to actually duplicate our point of presence everywhere, but maybe we could have edge. They were not called like that at the time, but we could have simpler, dumber services closer to the end users. So that way, at least for some category of content, so the cacheable, the reusable one, we could just ask the users to go there rather than go all the way back to the origin. And that saved a lot of time. If you're thinking, yeah, that's what a CDN is, absolutely. And in essence, Varnish is CDN software, so it makes total sense. Whether it's a private CDN that you own and control or a public CDN that you pay as a service, it's all CDN. After that, there was sort of a lull, but 10, 15 years ago, as the complexity of the services grew, there was a big trend which was, hey, how about we split the logic? How about we isolate concerns and components and go into microservices? So our origin now is not that one big monolith. It's an army of tiny, smaller programs and databases and multiple components. So everything is simpler, but there are more of them. Maintenance is easier. Upgrades are facilitated sometimes. But I needed to go with that detour because it feeds the next idea, which is, well, how about we grab some of that intelligence that we've now, fragmented, isolated, and how about we put it at the edge? Because the users still need to go back to the origin for the intelligence, computation, and that kind of stuff. So if we can put a tiny bit of the brains and put them at the edge, we reduce even further the number of times that our clients need to go to the origin. And this is where we go with or we come from with edge compute. But this is also where we go to. We want minimal latency. We want faster service to the users. And I've been very, very focused here on the latency because, yeah, I'm an engineer. I want that number to go low. But there are many, many other benefits, as we're going to see in the next slide.
Yeah, thanks, Guillaume. That's exactly right. So latency is obviously a huge part of sort of why we're seeing the movement towards the edge. I think there's a whole range of sort of interrelated challenges and opportunities that service providers, content providers are seeing that are sort of feeding into the growth of the edge market. So obviously there's latency reduction to enhance the quality of experience of whatever you're delivering. But there's also the fact that sort of content is becoming, high quality, high bandwidth, so that the performance needs of your network are, coming into question almost, or you need to really look at how you can deliver as much as possible with this high bandwidth content without harming resilience, reliability of your service. And this is all sort of links to the idea of being able to scale effectively and efficiently, right? So meeting the demands of both a growing audience and a growing amount of content that's being consumed. And obviously, in the end, it's a competitive market. It's a crowded market, a lot of time in the sort of content distribution space. So anything you can do to improve QoE or efficiency of scale, things like that are going to improve your chances of sort of thriving in a challenging market. So these are all things that processing data closer to end users can help with. So it's all about solving these different challenges with, well, to put it more, yeah, to put it simply, with one sort of solution, really. But I think there may be someone on the call now wondering why Varnish Software are talking about processing data when we provide content delivery software. It's a caching tool, caching technology in sort of the underlying guts of the software. So, Guillaume, why don't you set the record straight on the idea that Varnish only caches content?
Yeah, I mean, truth is we've been doing edge computing for the past 15 years. Stuff that requires intelligence, smart, like authentication, image optimization, cryptography, paywalls, throttling. All those are instances of edge computing. At the time, we didn't have that name. But yeah, we've been doing that for the longest time. And actually, it makes a lot of sense because Varnish doesn't necessarily see itself as a caching engine. And I think for that, we need to go to the architecture of the software and try to understand how it came to be and how we were so early in that space. And it's a very bright and simple diagram, but yeah, it has everything we need. At the bottom, you have the Varnish core, and basically, when Varnish started, its goal, its ambition was really be the fastest, be a very, very efficient HTTP engine. So the caching is sort of in the back of our head at that time, but the logic is really to be about efficiency, speed, and correctness. Having a reverse proxy that does HTTP properly. And as a result, it doesn't necessarily care too much about caching or caching rules and that kind of thing. So that's the reason for that VCL block here. VCL is Varnish configuration language. It's a programming language, put very simply. It doesn't have to be scary, but it allows us extreme control of what's happening. With it, we can observe the HTTP object as they are being received and sent. We can modify them. We can influence caching decision. Basically, we can build a throttling engine in pure VCL. We can decide pretty much everything on the flow of the request using VCL, and all that is being compiled into native code for awesome speed. I need to stop saying extreme, so I'm just going to awesome. And VCL is still concerned about HTTP logic. So on top of that, for very specific tasks that require a lot of performance, we have VMods, literally VCL modules. So they are libraries that from the VCL programming language we can use and leverage to do our bidding in a very precise and fast and efficient manner. stuff like cryptography or image manipulation, this is stuff that you want to go fast with. So vmods are our tool for that. So we go from something, the core, that's our base, that is very generic but extremely fast, to the VCL that influence the flow, to the vmods that are the tip of the spear, very narrow in scope, but they are purposefully designed for what we ask them to do. And that hierarchy basically allows us to have something that is still very fast, but that also allows edge computing with very, very little overhead.
Amazing. Thanks, Guillaume, for that rundown of the sort of building blocks of Varnish and where it came from, where we are today. I think that was kind of the kind of discussion about the software issues, things to think about in terms of architecture of the software itself when dealing with sort of performance and latency at the edge. I think the next point is really around, you can optimize the software, you can choose, highly performant software, but it's all about the underlying hardware needing to be, efficient, performant, and to provide the sort of scale and the value you need to deliver these edge workloads. And I think there have been a lot of advancements in the last few years in infrastructure that are really enabling the kind of edge workloads that we're seeing be rolled out. So I just wanted to touch on this briefly, because Varnish has been doing a lot of work in this area with infrastructure, with hardware providers. So I think it's a really cool part of the work we do with respect to edge. So Guillaume, do you want to talk us through the kind of things we've been doing in terms of optimizing
Absolutely.
software and hardware?
Yeah, of course. Yeah, because at Varnish, we are a software company, so we don't necessarily believe in just throwing more machines at a problem. I mean, it works. It's not really cost efficient. And also, we are passionate about performance efficiency. So we want our software to be the best it can be, of course. But to do that, we also need to work with everybody on the server, including the kernel. We are a Linux shop, and the hardware. And with that angle, we've had an amazing partnership over the years with the engineers at Intel. There are people who are also passionate about efficiency and performance. So their CPUs and their hardware in general is going to be the fastest possible. And we try to do the same thing. The issue or the tension that may arise is that we are probably going to make a few sacrifices or compromises to be extremely fast. And they do the same thing. If we talk to each other, we can make sure that our compromises are not going to step on their toes. And it's really just a symbiotic relationship here, because we know how to extract as much power as the chip was actually designed to do. So having been in that room with those engineers, it's an awesome experience. Seeing everybody at each layer of the stack working together to achieve maximum performance. As an engineer, it's an amazing feeling.
Yeah, and it's all about, as you say, fully utilizing the resources you have, right? That's how you get the most, yes, the efficiency, the value from your infrastructure. You're using it. You're all for performance.
Yeah, I
I guess
think
that's, yeah.
I think we go to the bragging slide now. Uh,
Yeah, so
because we
this
have
is,
just
yeah.
oh, you want to take it? Sorry.
No, you go, you go.
Um, um, all right. So the bragging slides now. Uh, those numbers are big, and they are bright, and they are bold. You probably don't need that much power, but those numbers were achieved with the top of the line of Intel's offering and latest version of our software. The important part here is that first, it's the current results. So as we keep on improving, as Intel hardware keeps on improving, we know those numbers are going to go higher and higher, meaning you can get more more data, more throughput out of a single server, and it's going to be cheaper and cheaper in terms of power. The important point is that you don't need top of the line hardware to benefit from that, because everything we learn at the software level, at the hardware level, it translates into slower, older machines. It means that we effectively extend the lifetime of the servers. They are still good. You don't need to throw them out. Um, our goal here is really to use the machines to their best potential. And I think, yeah, those numbers in a vacuum are not really that important. They are impressive. I really don't want to take away from that. But if you look at the perspective of it makes everyone better. It's an amazing uh, it's an amazing tech, basically.
Yeah, indeed. It's,
Did I get
yeah,
everything, Ian?
yeah, I think you did. It's kind of these sort of moonshot projects, right, that help us learn a lot, and then we can feed that bit back in to the software and all
Absolutely.
kinds of hardware. So it's, yeah, you can make massive performance gains just by, running different software on your existing hardware and getting greater
Yeah,
utilization from it. So if, I mean,
yeah.
if you, yeah,
That's actually, sorry. That's actually
sorry.
a good thing, a very good point, because I'm saying we want those machines to achieve their biggest potential. Our point here is not that we should use the machines as much as we can. It's we should let the machine perform as much as it can, meaning we should not be the bottleneck as software. So we try to be as efficient so that the machine can be used for other things.
So I mean, I guess that was a look at how we got to where we are today with the growth of edge computing and services moving to the edge and sort of the issues and topics that are important when it comes to building such services. But I wonder if you could give some closing thoughts on what's next.
Yeah, of course. Well, I mean, I think I already uh, hinted at that. The two bright green numbers that we saw in the previous slide, they're going to go higher. We want more speed, less latency. We want those servers to go as fast as they can, and we want that without compromising anything else, meaning security. We have an excellent security track record, so we want to keep that. And we've seen in the past that, yeah, there's sometimes a balance between speed and security. We really don't want to compromise around that. As the world is waking up to edge computing, we want to do more, possibly general purpose edge computing, which makes it even more important to be efficient, because all the processing power that we don't need to push data, then we can use it for other edge computing, arbitrary edge computing. And lastly, even though that's the first line on that list, if we want to push general purpose edge computing, we need a perfect pipeline. Because if you have a program and it's sitting on your laptop and you have no way of getting it into your cloud infrastructure, then it's useless. So the Varnish controller, the traffic router have been great additions these past few years, but they are going to be leveraged even more with what we've got in store. And yeah, that's it for me.
And there is a lot in store coming soon. We're going to continue working on all these different sort of aspects of edge delivery, edge compute, to continue this growth and offering big green numbers that we can brag about. But thank you, Guillaume. Thank you for your time today. That was super informative, super helpful. So I hope everyone also enjoyed listening, and you have something to sort of take away and think about. I just wanted to thank you and say, just if you're interested in finding out more about what Varnish Software can offer in terms of edge delivery, content distribution in general, and really just high performance caching, content delivery, please do reach out, get in touch, and until next time, have a great day.
Bye, everyone.